some maybe complicated things to get through here today. This is going to be the last set of lectures for this chapter. So, yes, Adam. I can't hear what you're asking. So this is where I was going. So today is going to be the last set of notes in this chapter. The plan is the next class period will take as like a general review day. I'll check in all the homeworks that I've had a chance to check in at that point, and answer any kind of last minute questions we might have. I divided this test into 2 parts because of the length of this chapter and the number of questions that are on there. One half of it is going to be on, for you guys, I think it's Tuesday, and then the second half would be on Thursday. So I've divided the test as kind of follows. The first half is going to be like more questions but shorter. So those should be quick questions to do, but there's more of them. The longer questions, I think there's like 4 or 5, and I put them all in the second test, or second half of it. It'll all go as one total score. But just to let you know, I tried to move it around in that fashion so that you have, like all the quick stuff to do on kind of on one day, and then the longer stuff is on the second day. But that's the general format. I'll get some details up on PowerSchool here by Monday for you guys, but that's kind of the general breakdown. Okay? All right. So today we're going to be talking about intersections. So stop talking, please. Again, today is probably the hardest set of skills for this chapter. So if you guys can focus on not snow days and on this, what's going on, all these things are eminently doable, but you have to kind of be paying attention, right? Nothing I'm going to do is going to be that bad, but it will be if you're only like half in. Okay, so let's stay all in for the 70 minutes. I know that's a tough ask, but I'm going to let you know right now, these are the hardest set of skills that we're going to talk about for this chapter. So the best we can focus, that would be better. So we're going to talk about the intersections of things in 3 dimensions. So there's 3 types of intersections you can have. You can have a line with another line, a line and a plane, and then you can have a plane and a plane. So we're going to look at all 3 of these situations here today. So the options for line and a line, you can have parallel, you can have overlapping, we can have intersecting, and then we can have non-intersecting, non-parallel. And you might think, what in the world would that look like? So imagine I have like 2 parallel planes, and maybe one line is doing this in that plane, and the other line is doing that in that plane. There's no plane in which those 2 lines are parallel, but they won't ever intersect either because they're on parallel planes. Right? So there's 4 options there. Okay. So that's the first place we're going to look at. We'll come back and deal with these other situations here in a moment. So for line and line, what we first do is we check to see if we're parallel / overlapping. So to do that, we're going to check, is one slope vector a multiple of the other slope vector? Okay, so for example, if we're to compare these two lines, my slope vectors are the parts that are attached to the parameter. So what I need to check is one of these a multiple of the other one? So is there a number k that I can multiply the one vector by to get the other vector? So if k is equal to -4, that's going to work. Everybody's okay with that? Okay. Now this is not going to tell me whether they are parallel or overlapping. All this confirms you is that they are one or the other. Okay? But I know that they are not going to intersect if the slope vectors are multiples of one another. Everybody okay there? So that's the first thing I need to check. So this means we are parallel or overlapping, but we don't know which one. So next thing, we'd say if we are parallel or overlapping, we want to check then to see if they are overlapping. To do this, to check to see if they're overlapping or just parallel, we need to see, is there a point on R1 that is also on R2, or vice versa? It doesn't really matter. So if I return back to this previous example that we just looked at, to tell the difference, let me just rewrite the two vectors here. Or the two, not vector, yeah, line equations. So I'm going to just check to see if this point is on this line. This is a skill that we've done before, right? Check to see if a line or a point lies on the line. What do we need to do to figure this out? We just need to see if these three equations all give me the same value for S, right? So I would be done at this point because I know R1 and R2 are overlapping. Let me explain to you how I've drawn that conclusion. I know R1 and R2 are parallel, right? Because they have essentially the same slope vector. And because I took a point from R1 and I found it on R2, the only way that two things that are parallel are going to have anything in common is if they are just the same line. They're overlapping. So that's what we've done. For this problem, we would be finished. We know exactly what type of intersection they have, and these two lines are overlapping. So if we had checked for parallel and we found the answer was no, the next thing we have to do is check to see if the lines intersect at all. Do you remember how we do that? We just set the two lines equal to each other. So let's look at a quick example of that. So this will be a different set of points, or set of lines, excuse me. Okay. First thing we do is we'll check to see if they're parallel. So is there a constant that I can multiply one slope to give me the other slope? So in this case, for the first component to be, I would need k to be 2/3. For the second component, I would get k has to be 5/9. And at that point, I can be done. Since the k's aren't the same, I know they're not parallel. So I'll check then for intersecting. To do that, I set the two equations equal to one another. Everybody's okay there? This is going to turn into the system of three equations. 2 plus 4t equals -2 plus -6s. 4 plus 5t equals -4 plus -9s, and then 1 plus -3t equals -1 plus 2s. Now really, how many of these equations do I need? I just need two of them because I have only two variables. So let's say I use the first and second equations only, and I'm going to rearrange these so that it's in a form that I can type into a matrix. So I've done a little bit of rearranging as I've done this. I hope that's okay with you guys. Everybody's okay there? So I'm going to then use this in my calculator to solve this system. When I do that, I get the matrix 1, 0, negative 2, and 0, 1, positive 2. So this tells me S equals negative 2 and T equals positive 2. But I'm not done. I still have one more thing to do. I have to check that these two values for S and T satisfy this third equation that we didn't use. If they do satisfy that equation, then the two lines intersect and we can find the point of intersection. If these values for S and T do not satisfy that third equation, then the lines do not intersect and they are not parallel. That's the third or the fourth possibility. Is that okay? Okay. So I have 1 plus negative 3 times 2 equals negative 1 plus 2 times negative 2. So I get negative 5 equals negative 5. So these two are intersecting. And to find where they intersect at, I'm going to just plug in either S or T into one of the two equations. Say I take T equals 2, and I plug it into the first equation where it has the T component in it. So that's going to give me 10, 14, negative 5. So there's where my intersection is at. Is that point 10, 14, negative 5. So to run through this again, first thing we do is we check to see if the two lines are parallel / overlapping by checking to see if one slope is a multiple of the other. If they are, we have to eliminate the possibility that they're overlapping by seeing if a point from one line is also a point on the other line. If they are, they're overlapping and you're done. If they're not, they're parallel and you're done. If they were neither parallel / overlapping, then you have to find if they intersect or not by setting the two equations equal to each other and solving that system. Once you get an answer to that system, you have to check to make sure it satisfies the third equation. If it does satisfy your third equation, they are intersecting, and you use those two parameters to find the point of intersection. If it does not satisfy that third equation, then you're done. They are non-parallel and non-overlapping. Okay with that, Brockton?
So you have how do you know?
So here are the S column, so those are the S variables. Here's the T column, so those were the T variables. So this says 1S plus 0T equals negative 2. That first line. The second line says 0S plus 1T is equal to 2. That's how. Is that okay? Yep. So I read it, I type the equations in, and then I read the matrix back out as an equation. Right? Each row is an equation. Bella, you had your hand up?
Yeah. How do you go to the last one so you can knock down the parallel with
Yep. I basically just solved each one of these rows for K, and if I get different numbers, then I'm done. They can't be parallel.
Okay.
If they're all the same, then it could be parallel or overlapping, and we have to check to make sure which one it is. Okay? Yes. Okay. Okay. So if I go back now to the beginning, the other option was a line with a plane. So the line could be in the plane. That's kind of like overlapping. The line could be not in the plane. That's kind of like parallel / intersecting non-parallel. Or the third option is the line could intersect the plane. Is everybody okay there? Okay. So a line and a point. All right, the first thing we're going to do is we have to check parallel. So the parallel is going to determine if the lines don't intersect, but they're parallel, or the line doesn't intersect the plane, but it's parallel, or if the line lies in the plane. To do that, we're going to take the slope vector from the line and set it equal to the two direction vectors from the plane. So what do we call those? S and T, I think, were the letters we used to do that. Okay, so quick example. I have an example here. Hold one quick second for me. Shoot. All right, I don't have an example put together right now for this. I apologize. I'm going to skip this. If I have time at the end, I'll come back and we'll write an example in this spot to do some of these things. But I'll have, okay? So I goofed up. I thought I had the example in here for this, and I guess I don't. So we'll come back to this. So what we'll do is we'll solve for A and B. We'll get an answer for A and B. And if A and B also check out, by plugging them into that third equation, then we have parallel or overlapping. So the second thing I would do then is to check for overlapping. So I'm going to take R0 and set that equal to my, so R0 is a point, is the point for my line equation, and I'm going to set that equal to my plane equation and see if I can solve for A and B and see if that checks with the third equation. If that checks out, that'll tell me they're overlapping. No would tell me they're parallel. Okay, so if they're not parallel or overlapping, the next thing we would want to do is to check if they intersect. To do that, we're going to take our line vector and set it equal to our plane vector. And here we would solve we get a 3-variable system. So we'd solve for T, A, and B. And we'd use let's see. So if this has a solution, it's intersecting. Like if I solve the system and I can get an answer, it's intersecting. If the solution or the system had no solution, it would be non-intersecting, non-parallel. And I can then use the values for A, B, and T to find the point. And really, I shouldn't say that. I should say use T or A and B to find the point. Really, I would use T because it's just one thing to plug in. It's a shorter equation. All right. Sorry about that. Halfway with no examples there. We'll come back and do some. I think we'll have time at the end for me to be able to squeeze that in. The last situation is if we have two planes. Two planes could be parallel, right? They could be overlapping, like they're really just the same plane. And the third situation is they intersect. But the intersection of two planes is going to be like a line. Just FYI. So when we find the intersection of two planes, what we're going to be finding is a line. Okay? Guess what we're going to start by checking? If they're parallel, you're seeing a pattern here. All right. In this class, though, I forgot. Okay, so let me see what I wrote here. Okay. Sorry, I'm going to go back up here for a second. So this is all correct. Okay, so when we have two planes, to show that they're parallel or show they're overlapping is actually quite difficult. We're not going to do that in this course. The only situation we're going to worry about is when the two planes overlap and a line is formed. I'm sorry, intersect and a line is formed. Okay, so that's the situation that we're going to deal with. So now I'm going to go back here. So we're only going to worry about intersectings. So let's just do an example here. I have one here. Okay, so here's my example. Here are my two planes. So if these two planes intersect, they should share at least one point in common, correct? So what that means is I'm just going to set the two planes equal to each other. So I can say that 1163 plus 1950A plus 215 negative 6B is equal to negative 245 plus 1264A plus 83 negative 4B. So if these are equal to each other, I can form a system of equations. So I can say 11 plus 19a plus 21b equals negative 2 plus 12a plus 8b. 6 plus 5a plus 5b equals 4 plus 6a plus 3b. Then 3 plus 0a plus negative 6b equals 5 plus 4a plus negative 4b. Oh my goodness. This is a problem. I needed to use a different parameter names here for these. I'm going to call these just C and D, because those are not necessarily the same parameter. My apologies. Everybody okay to hear, though, on what I've done? This should look familiar, right? Just setting the two things equal to each other and making a system out of it. We do this a bunch of times. How many variables do I have rattling around here? 4. How many equations do I have? 3. So things I'm going to have to be a little bit tricky here. I can still do this because of the nature of this problem, but this is why showing that the planes are parallel or overlapping is really rather hard. because it's quite a bit more complicated to deal with the 4 variables there than it is if we know they're overlapping, or I'm sorry, intersecting. Okay, so I'm going to rearrange these 3 equations to create a system by getting all of the variables on one side and then all of the constants on the other. So I'm going to now put this into my calculator. And then the tricky parts, or the sneaky part, I guess, is going to come. I'll give you everybody a chance to catch up before I do the sneaky part here. Are you guys ready to talk yet? Okay. So if I look at this first row, what does this first row say? It says I have 1a plus 0b plus 0c plus 1d should equal -1. If I look at the parameters there, a and d, are those on the same plane? No, right? So this equation I don't want. Let's look at the next one. If I look at the next row, this is 0a plus 1b minus 1d equals 0. Are b and d on the same plane? Or from the same plane? No. So I don't want that one either. If I look at the last one, I have 1c plus 1/2 d equals -1/2. C and D are parameters on the same plane. That's the equation that I want. Is everybody okay with that? Okay. Now what I'm going to do is just pick 2 pairs for C and D that satisfy this equation. So for example, if C equals 0 and D equals 1, that equation is satisfied. Everybody agree there? Or for example, if C equals 1/2 and D equals 0, that equation is satisfied. Does it matter how I find my C's and D's? No. All I need them to do is satisfy this equation that we just found from solving that system. Anthony, are you okay? Oh, thank you. So this should be what? That should be -1 then. And this one should be -1/2 there. Hi.
After school's fine.
Okay.
I'll go up to one class.
No problem, Miss Rubel. Yep. Is everybody okay with that? Thank you, Anthony. That's an important observation. If it feels like I'm forgetting something or I'm making a mistake, please interrupt. It's a lot easier to fix like 3 negative signs than it is to go back, like sift through a half a page of work and fill in the minus signs or whatever. You know what I mean? Okay, so we're almost done. I know. So this is what I needed. What am I going to do with this? Exactly. I'm going to generate 2 points from P2. So if I go back to my equation for P2, this was -245 plus 1264C plus 83 -4D. And if I plug in C equals 0 and D equals -1, I'm going to generate the point -10, 1, 9. And if I plug in -1/2 and then 0, did I forget the in? Plug in. That's going to give me -8, +1, and then +3. So I have 2 points. I can use those to create the equation for a line. So I'm going to say R naught is going to equal either one of those 2 points is fine. And my vector V is just going to be the difference in those 2 points. So my equation for my line is that. Yes. Thank you. Sometimes you just get going fast and, I don't know, I got excited. Thank you. Okay. Those were the situations. We have a few minutes here. Let's go and try to do a example here for this one that I've skipped. Sound good? All right. Okay. So here's my example. Here's my point in my plane. So what I would need, stop talking please, to check to see if these two are parallel, is I'm going to take that slope vector and see if it's equal to this part. Is everybody okay there? I'm going to turn this into a system of three equations. And I'm just going to take a pair of these equations. So I'm just going to take the first pair and use that to solve my system. Notice when I wrote that matrix, I put the whatever is on the equal sign on the right-hand side. It must be formatted that way, just as a heads up, that your equal sign must be on the far right in your matrix. So when I do that, I get A equals 1 and B equals -1. Is everybody okay there? So now the last thing I need to do is I need to check this. Since that gives me 6 is equal to 6, I know they're overlapping. Is everybody okay there? So I know that that line lies inside the same plane. If that didn't check out, it would be parallel and non-overlapping. So that line is like parallel to the plane, but in a different plane. If this part fails, then we know that we have a intersecting situation. Oh, I lied. So this is, sorry, I lied. This is going to be overlapping or parallel at this point.
Does it still apply that if it does fail, then it's intersecting?
If it fails, it's intersecting. Yes. So to tell between parallel and overlapping, we can check that. To do that, all I'm going to do is take the R0 from my line and set that equal to my plane. So in this case, that's going to be -10, 1, 9 equals to 11, 6, 3 plus 19, 5, 0, A plus 21, 5, -6, B. And just like before, I'm going to create a system of 3 equations, pick 2 of the equations, solve the system to get my values for A and B, and then check those in the 3rd equation. If they don't check, it's parallel and non-overlapping. If they do check, it's parallel overlapping. Is that okay with you guys?
Wait, what?
So I'm going to take this, make a system of 3 equations,
Okay.
right? Pick 2 of the equations out of the system and solve it for A and B.
Okay.
I'm going to take those A and B's and check it in the equation that I didn't use. If it checks out, it's parallel overlapping. If it doesn't check out, it's parallel non-overlapping.
Oh,
Okay? So like parallel overlapping means it's a line that's just in the plane. If it's parallel non-overlapping, it's a line that doesn't intersect that plane that's not in the plane, right? It's in some parallel
Are
plane.
you gonna show us how to do that, or are you?
I'm just kind of telling you.
Oh, okay.
Is that okay?
Yeah.
Because it's the same, it's literally the same work as here, right? It's this exact same work. I mean, their numbers are different, but it's the same work that we just did. Is that okay?
Yeah.
Okay. So if I wanted to do a example of non-parallel or just overlapping, would you like to see that? Do we have time to do that? I can set it up at least. It's okay? All right. You're good to stop? This was a lot, I know.